See, in the chapters which are previous to this chapter, which is called laws of motion, what do? We do not study physics. Okay? We use basic fundamental definition and mathematics. We have been using mathematics in the previous two chapters, which is units and dimension, which is motion in one dimension, which is motion in a plane, or also called motion in two dimension, right? In these chapters, you have been only simply using mathematics, okay? Clear? Particularly in the last two chapters, motion in one dimension and motion in two dimension, you guys have been very systematically using mathematics in order to find nothing but the past, the present, and the future position of a body. Nothing. How the body has moved, where it was, what was the initial velocity, what is the final velocity, what acceleration it went through, etc. 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 Right or not? How long it took, what displacement it did, right or not? आप यही कर रहे थे, whether it is one dimension or it is two dimension, right or not? Yes or no, guys?
Yes,
Keep
sir.
on responding, right? Fine. But now in this particular chapter, you will answer that one question which you did not ask yourself or no one literally discussed about. That is called, why ऐसा हो क्या रहा है? Which is making the body move. Why is the body moving? Clear? Sure. So
Yes,
from
sir.
this chapter onward, you will be discussing about why and how. Clear? Why is the body moving? How is the body moving? What is it doing and all? Clear or not? Sure.
Yes.
Fine.
Yes, sir.
Yes, sir.
Clear? Sure. So the answer to this is, why is the body moving? Because some force is acting. And the story started. See, Uncle Newton gets a good amount of credit for its work. But Uncle Newton literally did not do the researches by himself. Rather, I'll put in students' life. He had a very good notebook. Clear? So credit goes to him. Fine. He did what? Simply, we are discussing about motion from Aristotle's time. Okay? Sure, Aristotle started discussing about motion, Galileo came, many more people came. They explained to the world, opened their thoughts, shared them, but Uncle Newton recorded them, collated them, framed them, and presented to the world. Are we clear?
Yes, sir.
So in this chapter, we call it Newton's laws of motion, because in this chapter, Uncle Newton will be answering three prominent questions. Question number one, why is a body moving? Question number two, clear? How much of whatever is making the body move is required? Clear? And then comes the last question, from where that requirement is coming and getting fulfilled. So question number one, let's start formally. The chapter is called Newton's laws of motion. Question number one, what makes a body move? What makes a body move? So the answer to it is, Farhan.
So, an external force.
Okay, Aaron, is Farhan very correct in using the word
It's
external
only force.
force? Huh?
But then if it's already moving and yeah, it's only force actually.
Is
If
the
it's
word
like a
should be
flow or
only,
like
okay. Mr. Farhan
it's
said
like a flow.
external force. My dear friend Aaron is saying, sir, force word is enough. We don't have to add an adjective to it. Clear? Zorawar, what do you think?
Sir, external force, because when the body is moving.
Okay, vote
or
plus
it
for
will-
external force. Okay, good.
So,
Haan bhai, Shubhang, what do you think?
Sir, external force.
Okay, quite good amount of votes to external force. Shubhang, can you make an attempt to explain why external force has to be there?
Sir, if external force is not present, you can't move or do anything with the body.
Why? Can you just give an example?
Catching a ball.
Catching a ball, so I have to put external force on the ball to make it stop, to catch it, something like that.
Yes, sir.
Okay, how is an electric battery working then? There is a car, there is a remote, your remote, right or not? Clear?
Yes, sir.
Sure, fine. चलो ज़्यादा डेप्थ में चला गया. एक कार में बैटरी लगी हुई है, right or not? Sure. You switch it on, it will start.
Yes, sir.
Then how is it an external force? Chalo, right? You are correct. I'll elaborate. Okay, dear? Sure, you are very correct. Suppose all of us, okay, can we imagine a बहुत बड़ा साफ सुथरा कचरे का डिब्बा? Can we? Or a big bucket? Yes or no?
So
Yes,
can you repeat? I didn't catch the last one.
Can we imagine a big bucket? Yes or no? In which we can stand and it can tolerate our weight and size.
Yes, sir.
It can withstand our weight, it's not breaking and all that. Think that you are inside the bucket and now you have to move the bucket. Will you be able to push the bucket? So imagine. I will look very funny doing this, but for the sake of physics, I'll try. आप bucket के अंदर खड़े हो? आए. So, if you have to push the bucket, you will not be able to, right or not? Yes or no?
Yes, sir.
If
Yes.
I'll ask you, give you a challenge, let's have a bucket race, right or not? 4 or 5 of you are standing, even I am participating in that race, and we have to cross or 30 meters with that, right? How will we push? We'll slowly jump and push, right or not? Yes or no? Are yes or no, guys?
Yes.
So when we
Yes.
jump, we become an external entity for the bucket, and then only we can push it, right or not? Shubhang,
Yes, sir.
clear?
Yes, sir.
Everyone?
Yes.
Yes,
Right? Right, sure. So, internal forces can bring change into internal atomicity of the body, will not make the body shift its location. Are we clear? What happens in electricity? Electricity में in an electric cell, the internal chemical changes, not mechanical forces, internal chemical changes bring conduction, discharge, etc. But they will not make the cell move. Are we clear with this one?
Yes, sir.
Sure. Clear? They can
Yes.
activate a chemical process, but they will not make the cell change its position. Are we clear, Subhang?
Yes, sir.
Sure. Is it Shubhang or Subhang?
Shubhang.
Shubhang, no? I'm correct. Sure. So what makes a body move? An externally applied, and I want to add another adjective to it, beta. Sure. An externally applied unbalanced force. Clear?
Yes, sir.
Sure. It has to be unbalanced. Like this is a pen, right or not? I am applying 5 newtons from here. I am applying 5 newtons from here. I am applying a force, but the two forces are getting balanced out. Clear? And hence the net impact will be shunya. Clear? Hence, in order to bring change into state of motion, not only make a body move, rather, either if a body is moving to bring it into rest, or if a body is at rest to bring it into motion, right or not? For any such scenario, we use a single word bringing change in state of motion. Okay? Sure. For changing state of motion, we need what? A net external force. Here the net word is there. There should be a net outcome of the force. है ना? Unbalanced force means net outcome is something. Net outcome is not zero. Are we clear? Sure.
Yes.
Yes, sir.
Fine. And that's what was very well arranged as per Uncle Newton's first law. Clear? What was it? It is a body at rest will continue to be at rest. Yes or no?
Yes, sir.
Yes.
Or a body at motion will continue to be in motion until and unless a net external force acts on it. Are we clear, guys? Sure. A body
Yes.
which is in motion will continue to be in motion. A body which is at rest will continue to be at rest until unless a next external force is applied on it. Clear? Sure. Pakka?
Yes, sir.
But yeah, fine. So, question number 1 was well answered by Uncle Newton. The question was, why do bodies move, or what makes a body move? And Uncle Newton's good, beautiful, sundar answer was force. Yes or no? Clear? Yes or no? Right?
Yes, sir.
Yes, sir.
How he explained to the world in that era, think in that era he was thinking about robotic arms. Okay, so when we talk about Trinity College, you guys are aware about Trinity College? Bangaloreans don't say Trinity Circle, please. कि भाई रुक जा, समझा रहा हूँ यार, समोसा खा लेने दे, ठीक है? So he's saying कि imagine in that era, talking about revolutions, imagine there is a robotic arm, ठीक? So and imagine gravity सब हटा दी भाई अपन ने. No gravity, no air pressure, nothing, no friction, nothing, सब हवा में. अब सोचो, you have just sent an apple, Newton's favorite fruit, you know it, right? See? You have just sent an apple in the air. What will happen to it? बताइए. What do you guys think will happen to the apple? Gravity का है नहीं कि it will go down. हाँ है ना?
So it will just float.
There is no air friction that it will just stuck somewhere, right or not? No air friction, no air pressure, nothing. So you will say, sir, however you have left it, it will keep on going to that area. Yes or no?
Yes, sir.
Yes, sir.
Clear? So रास्ते में आके robotic arm ने उसका head टुकुक मार दिया. What will happen to it? It will change its direction and go into the direction of टुकुक. Yes or no? Clear?
Yes, sir.
So, exactly, when we think of all the natural forces to be removed, then we come to a case, yaar, theek hai. If there is no external force acting, things will keep on behaving how they are behaving. Yes or no? Clear?
Yes.
So, hence, he could conclude ki bhai, what I am saying is right. A force bring, a net external force bring change into the state of motion of a body. Clear? Sure.
Yes,
Yes,
sir.
sir.
But yeah, आगे बढ़े. Again same there, male toxic friends. कि भाई बता तो ये force कितना चाहिए? How much force is required? Clear? Sure. Fine.
Yes, sir.
Understood. Agreed कि a force will change the state of motion of a body. But how much force will bring what amount of change? Question number 2. How much force? So Newton started explaining. Can we have that interaction? You guys are not my toxic male friends, but fine. Fine. करे interaction करे भाई. सवाल number 1 goes to Aaron. Aaron,
Yes, sir.
suppose I am sending 2 bowling balls toward you. One is a 5 kg ball, one is a 1 kg ball. Both are coming toward you at same speed. In order to stop, which one you will need more force?
For the 5 kg bowling ball.
Obviously, so can I write force is directly proportional to mass?
Yes, sir.
Shabash. Farhan, there are two bowling
Yes, sir.
balls. Both are of 1 kg. But one is coming toward you with 1 meter per second. Another is coming toward you with 5 meter per second. In order to stop, which one will you need more force?
So the second one.
Right? So can I write force is also directly proportional to velocity?
Yes, sir.
Shabash. Zorawar.
Yes, sir.
So a strong man with strong name, 5 kg and 5 kg, chalega? 5 meter per second, 5 meter per second, chalega? This to be stopped
sir.
in 1 second's time and this to be stopped in 5 seconds time. For which one will you need more force?
For the first one.
So can I not say that force is directly proportional to time? Rather, force is inversely proportional to time. Right or not? Yes or no?
Yes, sir.
Yes, sir.
So if we blend these three lines, we reach down to where Uncle Newton reached. कि भाई मेरे force is proportional to mass velocity by time. Yes or no? Clear?
Yes, sir.
इसे कहते हैं मोमेंटम और नीचे लिखा हुआ है टाइम. राइट और नॉट? Sure. With further research, he concludes कि भाई सिर्फ momentum upon time is not the statement. Force is proportional to change in momentum upon time, because he later observed that in all these scenarios we were bringing some change. Right or not? Yes or no? Clear?
Yes, sir.
So force is not just proportional to momentum upon time, rather force is proportional to change in momentum upon time, and that is what Uncle Newton said as his second law of motion. Are we clear? Yes or no?
Yes, sir.
What Uncle Newton said in English was that force required is directly proportional to rate of change of linear momentum. Okay? Sure? Fine. This word linear got added by humans, us, our intervention later. Initially, Uncle Newton wasn't aware about angular momentum. When he's explaining all these things, he is naive about angular motion and all. Clear? He is only centric to linear motion. So he did not have word of linear. We humans, because we later study about angular momentum, have added this word. Are we clear? So force required is directly proportional to rate of change of linear momentum. Are we clear? Mathematically,
Yes.
it is F is proportional to change in momentum upon time. तो मैथमेटिकली हम इसको लिखने लगे भाई. हमने लिखा, हमने कहा भाई force is change in mass times velocity, right or not, upon time. मास तो चेंज होने से रहा. ऐसा थोड़ी ना होता है कि मैंने फरहान को धक्का दिया, फरहान के 5 किलो बढ़ गए, फरहान ने मुझे धक्का दिया, मेरे 10 किलो कम हो गए. काश ऐसा होता. मैं जिम ही नहीं जाता यार, मैं धक्का खा रहा होता बैठ के बस में. नहीं, हाँ भाई, दो धक्का ऐसे पॉसिबल नहीं है. So by just a mere धक्का we can't change the mass, the amount of matter in a body, right or not? Yeah.
Excuse me, sir.
Yes, dear.
Is momentum always represented as P?
Momentum in standard notations represented as छोटू p. Capital P is pressure. Okay.
Thank you, sir.
Sure. So, है ना? So by धक्का mass doesn't change. So what changes is change in velocity upon time. We write change in velocity as final minus initial upon time. Yes or no? Oh वाह 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 वाह, ये क्या हुआ? इसको फर्स्ट इक्वेशन ऑफ मोशन से एक्सेलरेशन कहते हैं. So we get force is mass time acceleration. The second law is also the definition of force. Are we clear?
Yes, sir.
Fine.
Yes, sir.
I just skipped one thing. It just reminds me now. I started going into that story of Uncle Newton. So in that conversation, we have missed about inertia. We'll discuss about. Don't worry. Okay? Clear? Sure. Inertia in itself is a 5 to 10 minutes discussion. मैं वो miss कर गया. Sorry. ठीक है? अभी when I say definition of force, each law out of these three laws, each law has a secondary name as well. The conventional name is first law, second law, and third law. Right now, they have a secondary technical name as well. First law is called law of inertia. Second law is called definition of force. Right or not? ठीक है? So with that I recall कि भाई अरे inertia तो छूटी गया. Don't worry, we will have a discussion. Are we clear and comfortable till here, guys? Yes or no?
Yes, sir.
Sure. So
Yes.
second law states how much force is required and what amount of force will bring what amount of momentum. Are we clear?
Yes, sir.
Sure. Comes to the second question. कि भाई ठीक है, agreed. In order to bring change into the state of motion of a body, you will need force. Agreed. Force will bring change in momentum. Agreed. अरे force आएगा कहाँ से? Question number 3. From where will the force come? And the answer goes like कि भाई मेरे force will come out of our actions as a reaction. Are we clear?
Yes.
Will come as a response to our actions. Clear? जब मुझे कूदना होता है तो I push myself down on the surface to get a reaction force to push me up. Yes or no? Clear? And that's what is explained in Newton's third law. Yes or no? Clear? Uncle Newton's third
Yes,
law
sir.
says every action will have an equal and opposite reaction. Are we clear? Fine.
Yes, sir.
Yeah. This law is called law of force equilibrium. This law is also called law of force equilibrium. Whatever goes comes back. Law of karma maybe also. Yes or no? Huh? So every action will have an equal and opposite reaction. When we walk, how do we walk? All of you at your growing age have heard this. ये आपका leg which is behind and leg which is forward. Yes or no? So this behind leg pushes the surface, hence the body goes forward. Yes or no? Clear?
Yes, sir.
So this is the
Yes, sir.
action point and hence the center of mass of the body. This is the reaction point. Clear? Fine. Swimming is a very, very, very smooth example of action and reaction. Jumping rather is a very, 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 very good example of action and reaction. Are we clear? Sure. So force applied by body 1 on body 2 is equal but opposite to force applied by body 2 on body 1. Are we clear with this line, guys? Sure.
Yes.
Fine. But so this is an introduction to the chapter. अभी chapter शुरू नहीं हुआ है फरहान मेरे भाई. ठीक है? Clear? So in this chapter, my dear
Yes.
friend, we literally had a bhumika, a backdrop of this chapter. ठीक है? Now in this chapter we have to understand where all in nature these forces can be evidently observed, and hence if there are problems and real world problems which can be solved by application of these forces, what are they? So we have already now studied and understood what are the three laws of motion stated by Uncle Newton, right or not? What will follow these discussions? These discussions will be followed by concept of tension, concept of friction. Understood? Clear? These
Yes, sir.
will be followed by concept of weight. Clear? Sure. And with vector application, these will be followed by balancing of multiple forces. Sure. Beyond these, we will also be discussing in this chapter applications, numerical applications of the three laws. What are they? From law 1, we have no numerical, it's just a statement based law. From law 2, we have numerical. From law 3, we don't have any numerical. Sure. Law 2 brings numerical to us. Count it be recoil ka concept. Recoil of a rifle, recoil of a gun. Sure. Count it be concept of conservation of momentum. Okay. Count it be concept of collision. Okay. Sure. These three prominent discussions will also be followed in this chapter. Are we clear?
Yes, sir.
Yes, sir.
Fine. ठीक है. So start करें.
Yes, sir.
ठीक है.
Yes, sir.
First thing I'll teach you here is, which is very important, resolving a vector into two components. Resolving a vector into two perpendicular components. देखो कैसे, कोई बहुत मुश्किल काम नहीं, बड़ा आसान. If we would have started with projectile a day, then we would have easily done it by now. But suppose, why there is a vertical axis and suppose there exists a horizontal axis. Clear? And if there is a vector, I'm just saying a force at an angle theta from the horizontal axis. Obviously, it will be at an angle 90 minus theta from the vertical axis. A simple thumb rule for life I will tell you. Out of the two components, whichever is connected with theta will be the cos component. Which is not connected with theta will be the sine component. Are we clear? Sure.
Yes, sir.
I'll mathematically also prove
Yes,
it.
sir.
So if I draw a replica of vertical axis here, then by right angle triangle I can very easily say that sine theta is equal to vertical upon the hypotenuse. Hypotenuse is force, right or not? Right? Sure.
Yes, sir.
So vertical axis
Yes,
is
sir.
nothing but f sine theta. In the same way I can say cosine theta is nothing but the horizontal upon the hypotenuse. So the horizontal axis is nothing but f cos theta. This is the maths behind it. Every time you don't have to follow, write the whole maths. Now you can memorize, and the crisp of memorizing is the side which is connected with the angle is the cos component. The side which is not connected with the angle is the sine component. Clear?
Fine.
Now there are three variations to this problem. Variation number 1, this is very easy, very straightforward. Variation number 2. Suppose there is a ceiling. With the ceiling connected is a thread, string. ओए कहाँ जा रहा है? Connected is a string. And with the string I have connected a bob. In this scenario there is no divergence of force. It's a simple acceleration due to gravity causing a weight of the body hanging downward. There is no inclination, right or not? Fine. But suppose the same hanging bob reaches here. So there is a weight here. नहीं खाना नहीं हुआ दोस्त, क्योंकि आरती नहीं हुआ, मेरी क्लास चल रही है मनीष भाई। आप लोग कब तक फ्री होते जल्दी बताओ। हो गए, अब इसको यहाँ रहने दो, खाना खाएंगे यहीं रहने दो, सुबह लेना, ठीक है? परेशान मत हो भाई, ठीक है? सो weight is acting downward, right or not? My question is, what is this weight doing? So you will say कि सर अगर आप ऐसे डिस्टर्ब करते हैं इस बॉब को, the weight has got two function. I will ask what? You will say कि सर function number one is to take this bob back to the mean position. Yes or no? Aaron,
Sure.
right? Also, to keep the thread stretched, right or not? Yes or no?
Yes, sir.
Means naturally you are not applying any force on it. So whatever is being done just by a single force, the weight force, right? So obviously the whole weight force is neither acting in this direction nor acting in this direction. Yes or no? Some part of the weight force is bringing it back. Some part of the weight force is keeping the thread stretched, right or not? Yes or no? Now my question is how much part? So you will say कि सर तो थीटा कितना है? तो मैं बोलूँगा मान लीजिए I have shifted it to theta here. तो आप बोलेंगे सर by 9th grade geometry this angle is theta. Tell me why. Which part? Alternate, corresponding, क्या?
Alternate.
ओए! Corresponding. देख, ये लाइन है और ये लाइन है, ये एंगल थीटा है इसलिए है, तो दिस इज करस्पॉन्डिंग ना? यस और नो? राइट और नॉट?
Yes.
हाँ, तो बिकॉज ऑफ करस्पॉन्डिंग एंगल सर दैट विल बी थीटा. तो जल्दी जल्दी बता दो which one will be mg cos theta and which one will be mg sin theta. फटाफट. The one taking it back will be quick.
So mg sin theta.
mg sin theta.
So,
Very good.
mg sin theta.
The one keeping it straight is mg.
So downward
Cosine.
will be mg cos
Why?
theta.
By the very basic rule, which is the side which is connected with angle is cosine, the side which is not connected with angle is
Theta,
sine.
sir.
Right or not?
Yes.
Clear?
Yes,
Version
sir.
number 3 of the same problem, beta. Suppose there is an inclined plane. ये 90 डिग्री है, ठीक है? And there is an inclined plane. If there is an inclined plane, suppose सोचो समझो जानो कि यहाँ पर एक डब्बा रखा हुआ है. I am very bad in drawing, so you have to at times imagine what I am drawing. ठीक है? Last time I discussed about recoil. मैंने ऐसे एक राइफल बनाई थी कि देखो ये एक राइफल है. Hey, see how beautiful and simple I draw the rifle. Huh? So at times, why you guys have to adjust with my drawing capabilities. Fine. Certainly you can't match them. They are unmatchable. You have to just keep the anxiety at place, है ना? और क्या बोलेंगे इसके लिए? Enviness. कि वाह यार क्या drawing. You have to keep it mum, right? So back to agenda beta. So there is a block which is of mass m. इसका भी weight is acting where? Weight always acts perpendicular to the ground. Okay? Sure? Surface, ground. Okay? Now what is this weight doing? This weight is doing two things. What? This weight wants the body to slide down. Yes or no? This weight keeps the body on the ground. Right or not? अरे हाँ या ना? अगर वेट नहीं होगा तो बॉडी
Yes,
विल
sir.
फ्लाई ऑफ. यस और नो? अगर वेट नहीं होगा तो बॉडी विल नॉट स्लाइड डाउन. राइट? सो यू नो इट वेरी वेल. राइट और नॉट? देखो अगर ये मेरा स्लेट है, ये मेरा कार की है, अगर मैं इसको इंक्लाइन करता हूँ बिकॉज देयर इज वेट हेंस इट इज गोइंग डाउन. वेट नहीं होगा तो नहीं जाएगी ना नीचे. राइट और नॉट? क्लियर?
Yes, sir.
So bhai, my question is, which part of mg, if the angle of inclination is theta, which part of mg is taking it down and which part of mg is
So
keeping
mg
it?
sin theta is taking it down.
Mg what?
Sin theta, sir.
Is taking it down. This one is sin theta. Why?
Yes, sir.
Why?
So because the cos theta is attached to the theta,
How?
and so between mg, those two angles which are made.
So you're correct, कि sir, between mg, yes or no?
Yeah.
And the
mg
cosine
and yes.
component which you have drawn, the angle is
Yes.
theta. How? Because of geometry. So this is 90, this will be 90 minus theta, right or not? So
Yes,
obviously
sir.
this will be theta, yes or no? The side
Yes, sir,
connected
that
with
will be
theta is
mg
mg
cos
cos
theta.
theta. The side not connected with theta is mg.
That will be mg sin
इसके
theta. Yes.
अलावा I am promising beta there won't be any variant of component of vectors. Okay, all the three possible components are plotted here. Okay,
Yes, sir.
ठीक है?
Yes, sir.
Sure. So इसके आगे का we will continue in another session. Are we clear and sorted till here?
So are we done for today?
Hmm.
So the class is till 10 o'clock.
चलो पढ़ते हैं फिर, ठीक है? Actually, my sevadars will be not going. वो ठीक है? They are like कि नहीं सर आप कर लीजिए. Anyway, proceed. No problem. Are we clear and sorted till here? This is not a core topic
Yes.
of the chapter. This one, resolving a vector, but it will be of huge application. Fine. Clear?
Yes.
Sure. Sure. So can we proceed?
Yes, sir.
Sure. To the three laws and their names. Law number 1 is also called law of inertia. So what is inertia? Inertia is a fancy name for being lazy. Yes or no?
So the tendency of a body
to
not
retain its
Retain,
state
yes.
of motion, oblique, to resist change in its states of motion. Right or not?
Yes, sir.
Clear? Sure. The capability to retain the state of motion or the resistance to change in state of motion. Okay. This is called inertia. Clear or not? You can use whichever version. Clear? Either retaining capability or the resistance toward change. Clear? Sure? Fine?
Yes, sir.
तो क्योंकि जब हम सोना चाहते हैं तो हम सिर्फ सोना चाहते हैं. कौन उठे सुबह बढ़िया प्लेजेंट वेदर ऑफ बैंगलोर, मैसूर एंड वेस्टर्न घाट्स है कि नहीं? श्योर. बट उठना पड़ता, मम्मी चप्पल मारेगी नहीं तो. खैर योर जनरेशन इज हैविंग अ डिफरेंट इक्वेशन. चप्पल तो नहीं पड़ती होगी. चप्पल तो हमें भी नहीं पड़ी होगी. आई डोंट नो आज चप्पल को भी पड़ी है क्या? नहीं यार, चप्पल नहीं पड़ी. What all I have been hit by many kitchen and stationery utensils. My mother was a teacher, so kitchen and stationery. ठीक. So back to agenda. Resistance toward change in state of motion is called inertia, or capability to retain the state of motion is called inertia. Inertias are of three types. वो रोबोटिक काम में वहां मिस किया मैंने, बोलता है टुडुक किया. Right? So not even to bring a rest or to stop from motion, to bring at rest or to start motion, you also need force to change the direction. Clear? So resistance is in three things: inertia to break the rest, inertia to stop the motion, and inertia to change the direction. गाड़ी मुड़ना नहीं चाहती है, गाड़ी सीधे चलते रहना चाहती है. आर वी क्लियर?
Yes, sir.
Sure. So we have inertia of rest, inertia of motion, inertia of direction. Clear? Fine. No one is going to ask you to write a comprehensive passage on it, but while solving numericals, we will be using these words. Hence, I am explaining. Are we clear? Sure.
Yes, sir.
Second law explains what? I have already explained. Second law explains force. है ना? Now here I want to highlight one thing. We in routine world don't come across things which change their mass. Okay, so we say by force is change in momentum with respect to time and it can come ma. Okay, we are happy with it. Fine. Parantu, in case of physics, there are certain bodies which changes mass on application of force. One such example is rocket. For a rocket, F is not equal to ma just for a very small time, that is when it is starting, F is equals to ma. After that, we have to write F is equals to mass times dv by dt plus velocity times dm by dt because the okay fine. Are हाँ है ना भाई?
Yes, sir.
Clear? Why do the mass of a rocket changes? It changes because of rapid combustion of fuel. Clear?
Yes, sir.
Yes, sir.
Yes, sir.
ठीक है? ओके, चलो आगे बढ़े. ठीक. Third law. What is third law? Writing pad at times. नहीं सही तो बन रहा है. There is a particular area where touch is going like gaga. Yes, yes, yes. Okay. Anyways, हाँ भाई आगे बढ़े. Equilibrium of forces.
Yes, sir.
So for every action there will be an equal and opposite reaction. Fine. Now if you observe very clearly beta, these laws are self-explanation of each other. जैसे फर्स्ट लॉ सेज कि अगर फोर्स जीरो होगा तो देर फर्स्ट लॉ कहता है कि चेंज इन मोमेंटम तभी आ सकता है जब फोर्स आए. चेंज इन मोमेंटम सॉरी. यस और नो? A body will change its state
Yes.
of motion positively or negatively. Towards stop is negative change in momentum. Towards speed up is positive change in momentum. Right or not?
Yes, sir.
Okay?
Yes, sir.
Sure. So, change in momentum can only be brought with some presence of force. So, in this expression, force is equals to change in momentum upon time. If force goes to zero, change in momentum goes to zero, it is nothing but force. Yes or no?
Yes, sir.
Clear? Fine.
Yes, sir.
Okay? So, these laws are self-explanatory of each other. Clear? ठीक.
Yes, sir.
Can we proceed? Application
sir.
number. Is tension there in the syllabus, beta?
Yes, sir.
Then very good. So देखो tension में क्या होगा? Tension is a consequence of third law. Tension is a consequence of law number 3. कैसे? देखो. If this is a ceiling and a mass is attached or hanging on this with this, ठीक है? Where is the mass going? Nowhere. Mass is standing, right or not? Clear? Yes or no?
Yes, sir.
अच्छा. How many forces are acting there?
So one gravitational force.
Any other
weight and
information of tension stored, the answer will be weight, sir. Right or not? Clear? Sure. But we also know that yeah, if there is only one force acting downward, the body should be going down by first law. Yes or no?
Yes, sir.
But the body is not going. That's what is the idea. How the ideation happened is what I am explaining by these sentences. कि भाई the first person to observe this was like यार mass एक ही डायरेक्शन में तो फोर्स लग रहा है, ये बॉडी नीचे क्यों नहीं जा रही है? Yes or no? Clear?
Yes,
To
sir.
realize कि ओए होए 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 every action has an equal and opposite reaction. So the string is having a restoring force against the direction of applied force. Are we clear?
Yes, sir.
Sure. Which is acting upward direction. So tension always goes away from the mass. Understood? Like if there are two masses connected by a string, okay, and I have now stretched them. So the tension here is going away from this mass. The tension here is going away from this mass. Are we clear? So tension as
Yes,
a
sir.
whole
Yes, sir.
comes toward the center and nullifies each other, but generate an impact throughout the string. Are we clear? So hence, when we pull the string from wherever, it breaks from the center. Yes or no? Right or
Yes,
not?
sir.
Because the pull is generating a tension which is reaching where? The center of the string, and that causes the break. Are we clear?
Yes, sir.
Sure. So the tension is a response force to weight. Clear? Fine.
Yes, sir.
Okay. Now here, as the total force is 0, so the downward force is equals to upward force, right or not? Tension is
Yes.
the upward force. mg is the downward force. So the downward force is equals to upward force. In this case, T equal to mg. खाना खा लें यार भाई लोग, गड़बड़ हो जाएगी. है? टेंशन यहाँ से आगे चलाएंगे हम. क्लियर? श्योर?
Yes, sir.
पक्का?
Yes, sir.